All right, I'm going to use the sum and difference equation for trig functions, formulas actually, to solve these problems. Both of these are given, all these problems are given the triangles of the special triangles that you know of, the 30, 60, 90, 45, 45, 90, or quadrantal triangles. So the first one is sine, and it's minus. So I'm going to look at my formula sheet, and the minus one tells me to go sine of A, which is going to be, this is going to be my A, and this is going to be my B. So sine of A, which is 45, times cosine of B, which is the 30, and then it's minus, and with the sine one, they stay minus, then minus, and then I'm going to go cosine of A, which is the 45, and then I'm going to go sine of the B, which is 30. So now all I have to do is figure out what cosine of 45 is, what sine of what sine of 45 is, what cosine of 30 is, and so on. So I'm gonna just write the triangle in here for this one. So 45, 45, 90 goes 1, 1, radical 2, radical 2. My 30, 60, 90. I just happen to put them in those spots. Goes 1, 2, radical 3. Okay, so now I think the sine of 45, sine again is opposite over hypotenuse. So I'm looking at my 45-degree triangle, which is right here, and I want to figure out, I'm at 45, so I can pick either spot, and it's opposite over hypotenuse. Opposite the angle over the hypotenuse, which is always across from the right angle. So that's going to give you 1 over the square root of 2. Some of you know how to clean that up. Jump right to that if you want. Okay, now I'm going to look at the cosine of 30. Cosine, I'll write that down. Cosine is adjacent over hypotenuse. So I'm going to go to the 30 spot. Okay, and adjacent is the side attached to it, and the hypotenuse is across from the right angle. So the adjacent side is the radical 3. The hypotenuse is the 2. So this is going to be radical 3 over 2, and I'm going to multiply those guys together in a second. All right, then I'm going to do the cosine of 45. So cosine of 45 is going to be the same as sine because it's just the adjacent over the hypotenuse, and the adjacent is also 1. So that gives me 1 over radical 2. And then the sine of 30, I'm going to stand at the sine position of 30, excuse me. Opposite over hypotenuse is just 1/2. All right, I'm going to clean up the ones that have the radical in the denominator, so this guy and this guy, which are going to end up being the same thing, which is nice. Okay, so to clean that up, again, all I want to do is take, I'm going to go 1 radical 2. To get rid of the radical 2, I need to multiply by radical 2 over radical 2, and remember, radical 2 over radical 2 is just 1. That's why I can do that, and anytime you multiply something by 1, you get 1 back. So that gives me radical 2 over 2 over radical 4, which is 2. All right, so that is what this really is. So I have radical 2 over 2 times radical 2 over 3, and then minus, I can change that now, radical 2 over 2 times 1/2. Okay, multiply the fractions, multiply the numerator, multiply the denominator. So this is going to give me, so this is out of the way, I got radical, the square root of 4 over 6 minus okay, did I do that backwards? I'm sorry. So I'm going to fix that. I flipped that for some crazy reason. So that's not 6 and that's not that. So this was actually radical 3 over 2. Sorry. Okay, so that's going to give me a radical 6 over 4, and then it's minus radical 2 over 4. And then generally, that's what's going to happen. You're going to get the common denominator. So I'm going to have radical 6 minus radical 2 all over 4. And that is my answer. It's a funky answer. Most of the answers are going to look very similar to what I just wrote down when you do these. Okay, all the ones we're going to do are going to be the triangles that you know of. So the next one is cosine of 180 plus 45. So it's cosine now, so I got to make sure I'm using the cosine formula. And it's addition. So cosine, so this is my A, and this is my B. Okay, so cosine, when I add, I'm going to actually subtract when I do this in the problem. So I'm going to say cosine of 180 times cosine of 45. And then I subtract, I do the opposite of what I would probably want to do. And then I'm going to do the sines of 180 times the sine of 45. Okay, I already have my triangles. Now, 180, I know cosine of 45 is, I'm going to just jump right to it. It's 1 over radical 2, but I know that's going to be radical 2 over 2. So now that I've done that rationalizing already, I'm going to just use that. And then I know the sine of 45 is also radical 2 over 2. Okay, so for 180, I want to use my unit circle. So over here is 180, and I know this is 1 comma 0, and over here would be negative 1 comma 0. And I know that cosine is the x value, and sine is the y, kind of alphabetically. All right, so therefore, I want the cosine of 180, so that's going to be negative 1, and I want the sine of 180, which is 0. And look what happens here. All right, so for this particular problem, 0 times radical 2 over 2 is going to be gone. So this is what my answer is going to be. So I'm going to have a negative radical 2 over 2 minus 0. So my final answer is negative radical 2 over 2. And that is how we would do that one. All right, so this one came out to be a simpler answer because there actually is another way. If you put 180 and 45 together, you guys are able to find what that angle is because we've done that before. That's a special angle also. So there's 2. We'll do 2 more examples in a sec. All right, so here's these 2 examples. I already redrew the triangles on here, so I have something to look at. Just for future reference, because this is where we're going to head to, 45 minus 30 is actually 15. So what we're really finding is we're finding the cosine of 15 in a distorted kind of way, and that's where we're headed to after this. Okay, so if I do this one, if I do cosine of 45 minus that, so I'm going to use the formula for minus, which really means to plus. Okay, so here we go. So this is actually the cosine of 15, like I said, but we're going to break it up like 45 in there. So we're using the minus cosine 1, which is the cosine of A, which is 45, times the cosine of B, which is 30. And then for the cosine formula, you always add, you do the opposite. Now we do the sines of those same ones. So sine of 45 times sine of 30. Okay, now I'm going to figure out what these are. So the cosine of 45, so 45 is here. Cosine is adjacent over hypotenuse, so it's just 1 over radical 2. We know that we want to conjugate that. So it's going to be radical 2 over 2, and then we're going to do multiplied by cosine of 30. I'm at the 30. Cosine is adjacent over hypotenuse, so that's going to give me radical 3 over 2. And then we're adding to that, the sine of 45 is 1 over radical 2, which is radical 2 over 2 when you clean it up. And then the sine of 30 is opposite. I'm standing at the 30. Opposite is 1. Hypotenuse is 2. So it's 1 over 2. And again, we do these enough that pretty soon you're going to remember the sine of 30 is 1/2, and you just insert it, or you did it on the last problem, so you just keep using it. All right, none of these have to be cleaned up. We're good on that. So we're going to multiply, and multiplying means multiply the numerators, multiply the denominators. You can multiply a radical with a radical. So this gives me radical 6 over 4 plus radical 2 over 4, which looks very similar to the last one we had. And we get radical 6 plus radical 2 all over 4. Don't add the radical 6 and the radical 2 because in order for radicals to be added, remember they have to look exactly the same, and then you would add the leading coefficient. So that's my answer. They're all going to look like very similar to this. All right, let's look through this last sine one. So now we're back to sine and it's adding. So sine with adding, we keep the adding in the middle and we use each of the trig functions and then add each of the trig functions again. So I'm going to start with sine of A, which is the 60, times cosine of B, which is the 45. And then again, we're going to add, whereas cosine does the opposite, sine does the same. Now I'm going to find the cosine of A times the sine of B. So I kind of use each of them in a different spot. All right, sine of 60. I didn't do this on this page, so let's check it out. Sine of 60, go to the 60. I'm here. Sine is opposite over hypotenuse, so radical 3 is the opposite side. The hypotenuse is the 2. So radical 3 over 2, and then I'm going to multiply by cosine of 45. We already did that right up here, so we're going to remember that's radical 2 over 2. And then I'm going to add to that the cosine of 60. We didn't do that on this page, but 60 is here. Cosine is adjacent over hypotenuse, so that gives me 1/2. And sine of 45, again, we already did that. We did that up here. And I know that is radical 2 over 2 also. So notice the cosine of 45 and the sine of 45 are the same value. All right, so now I have that. My denominators are don't need to be changed. They're in good form. I'm going to multiply. Again, I can just multiply radical and radical, and lo and behold, we're going to get a similar thing again. So I get radical 6 over 2 plus radical 2 over 4. Excuse me, that last one, that was my mistake. That should be a 4. 2 times 2 is 4. And looky, looky, we get radical 6 plus radical 2 over 4. And that would be my answer. Okay, so what we just found is actually 60 plus 45 is 105. What we really found just now was we found out what sine of 105 is. Normally we couldn't do that because 105 doesn't have a good reference angle. 105's reference angle is 75, and that's not super useful for me. So with this is the whole point of doing this. This is how we find the angles that are funky. We use the sum and the difference formula. So there's 4 examples. Get